Archimedes principle. Here's what happened, and that will lead us to the Archimedes principle. There was a king, and he did not trust his goldsmith. He ordered a crown to be made, and he was like, the crown had weird shapes, right? And it had like all these gems and everything. And he wanted to figure out whether the goldsmith was actually putting in pure gold in his crown, or did he not put in pure gold in his crown and was like cheating him, right? By putting in some brass or silver or something else into the mix. So what he said was, I will give, I don't know, $1 million to whoever figures out if this gold, I'm just saying, right? Of course, they were not dollars. I was just saying, he said there was going to be a prize for whoever figures out if this is pure gold or not. So he gave this task to everybody, and they tried to calculate the densities, mass over volumes, but they couldn't because it had weird shapes. Archimedes went home, and he was in the bathtub, and his servants filled the bathtub up to the brim. And when he got in, guess what happened? The water overflowed, and he was really mad. So then he got up from the bathtub, and then he realized, oh, so the amount of water that was displaced from this bathtub equaled my mass. So the way I would tell how much the crown weighs with all its indentations and everything, and, you know, because me being a guy, it calculates my volume by the water displaced. And so he was able to figure out. So then the story goes that he got so excited that he didn't put on any clothes, and he ran down the street to the king's palace to tell him, I figured out the way to calculate the density of your gold crown that will tell you whether the crown was true or not. But that's the same guy. Okay, so the idea is that Archimedes said that the amount of buoyant force on an object is equal to the water it displaces when you put it inside something. So if you have a bucket of water, you have water, you try to put in something in this water, what will happen? This water level will rise. Agreed? From here to here. The amount of water that will rise is directly proportional to the mass of the object. So how do we write that? Sigma F equals the buoyant force minus mg. I put this in water, mg goes down, and the buoyant force is what's pushing it up. Is it accelerating? So that means FB equals mg. Can I write m as rho v? And that's the buoyant force. Where FB is called the buoyant force. This is the density. This is the volume displaced. Other thing that you should know is if I place this object in water, what will be the pressure? As I go deeper and deeper, will the pressure increase? And will it increase equally on all sides? Is that going to be true? Sorry, these arrows should be equal on both sides. I'm gonna,
Yeah.
it might be easier if I just do that. You get the picture, right? As I go deeper and deeper, the pressure increases. So if the pressure is P here, the pressure will be P plus dP here, increasing as we go down. So do you guys want to write the formal definition of Archimedes' principle? There is one. Archimedes' principle states, when a body is immersed in a fluid, there is an upward resulting force exerted on the body by the fluid that is equal to the weight of the fluid displaced by the body.